Today we will be going over section 9.2, multi-stage experiments with and without replacement. Our objectives for today, students will be able to understand and explain multi-stage experiments and independent events. We'll start with a definition of multi-stage experiments. So they are completed in multiple steps and are done with replacement or without replacement. So some examples would be flipping a coin twice or rolling a die twice. So here's a representation of sample space in a multi-stage experiment. So suppose you toss a fair coin 2 times and record the results in order. So now we'll look and find A, which will be the sample space for this experiment. So we'll come down here, sample space is going to be S equals, and we'll put brackets, and this is going to be all the possibilities from flipping that coin 2 times. So you could do heads to heads, a heads tails, tails heads, or tails and tails. Then we'll look at B, so event A of tossing a tails on the last toss. So we'll come down here and that'll be A equals brackets, and there's 2 possibilities for this. So it would either be HT, heads and tails, or tails and tails. So now we'll look at our multi-stage experiments with replacement. So let's suppose you have a box containing 3 different colored marbles. So one is red, one yellow, and one is blue. So you're going to draw a marble from the box, record the color, and the key is you're going to replace that marble, and then you're going to draw a marble from the box again and record that color. So looking at our tree diagram here, this will have all of them have an equal possibility of being drawn. So we're going to look right here, 1/3, 1/3, 1/3, right? There's 3 marbles in the box, so each has a 1/3 chance of being drawn on the first one. So then we'll look, you're going to put that color that you drew on the first one back in the box, so you're still going to have those 3 marbles. And for your second draw, you're going to come out here and branch out from those first ones. So you'll come here so they each still have that 1/3 possibility on each color, right? So we'll look over here, and our tree diagram has the sample space. So RR, RY, RB, and continuing on and on, you have all these that you can draw from that tree diagram. It's very easy to see there. And then each outcome in the sample space is equally likely, right? So there's 9 total outcomes, okay? So the probability of the event containing each separate outcome, so each one of these, right, is going to be 1/9. We can also look here, this is the same example, but you're going to put them in a table. So you have all the possibilities here. Your first draw is over here, second draw here. So you do red on the first one, red on the second one, it's going to be RR. You do red on the first one, yellow on the second one, it will be RY. All right, and you continue on down this table here. Looking at independent events, so when the occurrence or non-occurrence of event A has no influence on the occurrence or non-occurrence of event B, the events A and B are independent. So let's look at our example. 2 coins are flipped. Event A obtains a head on the first coin. Event B contains a tail on the second coin. Event A and event B are independent events because the outcome of the first coin flip has no influence on the outcome of the second coin flip. So right, they're 2 separate coins. They're not going to have any effect on each other. So now we can get into our multi-stage experiment without replacement. So we'll first look over here at our side note here. This is going to be when the occurrence of event A has an influence on the occurrence or non-occurrence of event B. then events A and B are dependent. So that's when they have an effect on each other, they are dependent. So let's look at our example. So the box below contains 8 letters. Suppose 5 letters are drawn at random from the box one by one without replacement. So we're going to look at the probability of the event consisting of the outcome chain with the letters chosen in exactly that order. So they have to be CHAIN, okay? Look at our next page here. So multi-stage experiment without replacement continued. We're going to keep looking at that. So looking at the portion of the tree branch leading to the outcome chain, and I think I'm covering the answer choice there, but that's okay, we'll write it out. So we have without replacement, right? So you have a 1/8 chance of drawing a C, okay? And once that C is gone, there's going to be 7 letters left. So there's a 1/7 chance of getting an H. Then there's going to be 6 letters left after that. So you have a 1/6 chance of drawing an A. After that, there's going to be the 5 letters left. So 1/5 chance of drawing an I. And after you draw that I, there's going to be a 1/4 chance of getting an N. So to get the probability of it all, what we're going to do is multiply all of these, right? So we can go in. We know 8 times 7 is 56, right? Then we'll do 56 times 6 is going to be 336. And then we'll do 336 times 5 is going to be 1,680. And then we'll do that times 4. And that's going to be 6,720. And that's going to be for our denominators. And we look at the tops, they're all 1s. So that is going to be 1/6,720. And that's our probability of the outcome chain.